The first algorithm is KNN, which is called as K nearest neighbors. K nearest neighbors. Okay, this is the algorithm's name. So what is the job of the algorithm? Job of algorithm is to give me this h, give me this function, so that if I give it a query point, so it should give me the corresponding label. So here I want to find this h such that if I give it some xq, a query point, it should give me the corresponding yq. And how should this yq be? Loss should be minimized. So loss should of this h onto a data set, it should give me such an h from this h such that this is minimized. So this is my loss. I want to minimize this loss. Okay, I'll compute the loss based on this yq. So this is the whole point. So KNN is one of the algorithm which will do that. Let me ask you a question, which usually I'll do with the students whom I teach this KNN. So let's suppose I'll make a data point. I want to tell you where to fit it. So let's suppose this is value 1, this is value 2, 3, and let's suppose 4. So I'll put the values like this. So if I have a point over here, okay, so if I have a point over here, so what will be the corresponding y value? Let's suppose for this point, the corresponding value is 1.5 for this point. So I'm saying if I have a point over here, over here, so what will be the corresponding value of this? Any guesses? Now you have to see the y values. Y value. Yes.
3, sir.
So you're assuming it to be right here, like nearly right here. Okay. So now you made an implicit assumption. Okay, you made an assumption. I'm not saying you are wrong or right. So it was up to me. How did I? Maybe I said the function is not like this. The function is basically this, something like this. So it was up to me how to make a function. But here you made an implicit assumption. That's what I wanted to capture. Implicit assumption was there. You said you what is called as interpolation. You said probably this will form a graph like this. If I enter with the graph, you guess it. The graph will be like this. It's a good guess. I won't say it's a bad guess. It's a good guess. But what can happen also is, the thing is, this function could have been a little different. This function could have been like this. This function could have been. Oh, let me draw it. And then it could have been like this. It would have never passed through it. Something like this. We don't know. But you made an implicit assumption that if you have a point, so it will follow. It will basically follow a pattern like that. That's what I am saying. So whenever you have data set, you have to make some assumptions which model to use. Okay, so here you made an assumption. Again, I'm giving some other example. I again want to do you the same thing. So I'll again capture your assumption. What is the assumption that you made? So here you made one assumption. You interpolated things. You said that probably the graph will look like this. Okay, now let's suppose I have two sort of points over here, and then maybe let's suppose I have some circles over here. That's why you have to look at the data in order to make a model. And maybe if I have some other class, I'll try to get circles. So I have only two classes. So let's suppose if I put a query point over here. So this is my query point. So does it belong to the red class or does it belong to this purple class? What will you say? Which class does it belong to this point?
Purple. Yes, sir.
So you'll say it belongs to purple class. Again, you made an assumption. So what is the assumption you made? It's a really good assumption. I won't say it's a bad assumption. You made an assumption. So the assumption here was that if the point is lying near to some point which are in neighborhood, then it belongs to that class. Okay. So this was the assumption you made. So similar points are clubbed together. So similar data points are clubbed together. What is that? There is that quote: "Birds of some feather flock together," something like that. So you made an assumption over here. Now this is the total KNN what we did. This is K nearest neighbor algorithm. I'm done. This is only K nearest. If you understood that this is K, now you just have to mathematically model it and just make an algorithm out of it. Now you implicitly made an assumption about the data that is similar points are clubbed together. This is my data and this is the K nearest, and it is really, this algorithm is actually performing good. It was, I think, 1967. It was, this algorithm was found. There was nothing special about the algorithm though. So the assumption was these birds of same feather flock together. So if you have a data point which is closer to, that's why it's called neighbors. So if it has some neighbors, it belongs to these points. Okay, so that was the assumption. So you see how simple ideas can turn out to be like really brilliant. Isn't it a simple idea? How many of you feel it's a simple idea?
Yes,
Really
sir.
simple.
Yes, sir.
It's a really simple idea. Now, how it turned out to be elegant is how you model it. So that's why it's called KNN, and it really performed good. 1916. That's why learning is required. So before this, if somebody would have told you there's an algorithm K nearest algorithm, maybe they might introduce in some other sense. They will give you mathematical a lot of details without telling you underlying what it is. So, but after this, you should feel like this is not a new algorithm. This is an intuition algorithm. So the best part, whoever discovered this in 1967, the benefit they had is they were born before me. Isn't it?
Sir.
So that's why I'm telling most of the times people have the benefit because they were born before me and they were able to discover that. Okay, that's the feeling you should get. Yeah, this is so intuitive, yeah. I should have easily discovered it if I was present at that time. So now I need to do this. What I need to mathematically model this. So here let's suppose these points I'll call them as positive points, and here I'll call these red as negative points. So I'll write it right here. So these circles are negative points, and these crosses they are positive points. Okay, and here this gray over, let's suppose a Curie point. You know, the best thing about KNN is it doesn't require test training. So you have data, you directly do it. Okay, that's the now I'll show it to you geometrically. So what you do is you find similarity, of Curie point with its neighborhood. What does that mean? That means that, for example, you have a Curie point and you will see its neighbors, and you will see if the neighbors are, let's suppose, of one type, then it's of that type. Okay, so if the majors are of multiple types, then you'll do a majority vote. Okay, so what you do is you will basically find k nearest neighbors. That's why it's called KNN. So you will pick k neighbors. Let's suppose three neighbors. So here you will pick three neighbors. So this guy is a neighbor, this guy is a neighbor, this is a neighbor. Let's suppose this is the nearest, three nearest neighbors. Then you will see all of these three are these purple crosses. Then you will say this Curie point is also a purple cross. This is also a purple cross. That's what you have to do. That's the all thing you have to do. Okay, so if I write the algorithm, so what is the algorithm? Then I also mathematically say, like, write mathematical equation. The algorithm, the first step is find k nearest neighbors. Find k nearest neighbors. Okay, and when you find this and get their labels, so when you get their labels, second is do a majority vote. Usually, let's suppose this k here, you have the control how many neighbors to choose. So this is called as hyperparameter. Okay, let's suppose k is 3. So here, if all the 3 points were positive, 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 you will directly say the Curie point belongs to positive. If the neighbors were positive, positive, negative, so you will say it also belongs to positive. If it is a negative, negative, positive, something like this, so you will say it belongs to negative class. That's why usually you don't choose this k as even, because sometimes it will happen positive, positive, negative, negative. So then you will be in a sort of dead situation with which to capture. So this is up to you what k to choose. So it's better to keep it as an odd number. Sometimes we have other forms of KNN. So by using this KNN, I'll introduce a lot of concepts. That's why I chose the simple algorithm, so that I can also introduce what is this k-fold cross validation, how do we test it, how do we do a lot of things, what is overfitting, what is underfitting. Okay, so I wanted to introduce this KNN so that I can use this leverage this algorithm to explain the other concepts. That's the reason it's so simple. So what is the thing? So you will find the k nearest neighbors and get their labels. Maybe, so let's suppose their labels were y1, y2, and y3. You will see what the labels are these, and then you will based on that decide it. So how to mathematically capture it now? Okay, so what am I doing is I am taking some sx. Sx is a subset of d. So sx is a subset of d. If I write it mathematically, see how I write it mathematically. So sx is subset of d. This means, and sx has the cardinality of k. So there are two meanings in here. The first thing is this sx is a set of neighboring points. Set of neighboring points. So how many neighbors are there? K. Cardinality is K. Okay. So and what I had to say, I said for all. Let's take 2 points. Let's take this point x and any other point x dash. So this x is our point and x dash. Let's suppose these points belong to data set. This is a data point. Let's suppose I will say x and y. So this is one data point. Let's say for all data points x comma y. This is one data point. This is its label and this is x. For all which belongs to data set but does not belong to sx. So I'm saying for all data points. So we have data set. Now we said a neighboring part is this sx. This is our sx. This is the whole d was this. So the remaining part, this blue is the remaining part without this sx. So I'm saying for all these points. So for all these points should be there. So distance of, so I'll write distance d as distance of this x comma y should always be greater than maximum distance of the points which basically belong to maximum distance of points x dash comma y dash, and this x dash comma y dash, they belong to this sx. Again, reading is mathematics. It will be a little bit complex for you guys because it's the first time I'm writing this English into math. So I'm saying, so if I take this sx is the set of points which are neighbors to the Curie point, that xq. We have this Curie point xq. Okay. So I'm saying if you compute the distance of this xq to any point which belongs in this blue region, it should always be greater than the neighbors. So that means the neighbors should have less distance. Did you understand this point? So how many of you understood this
Yes, sir.
point? So I'm saying this s of x is a set of neighboring points. D is the whole data set. Just remove the neighboring points from the data set. I'm saying if you measure the distance of this xq and xq to all the points that are in this blue region, that is the data points which are not the neighbors, they should be always greater than the maximum distance whatever it had with the neighbors. So that means in simple it means neighbors should always be closer. Okay, you should have a lot of affection towards the neighbor. Neighbor should be close. That is the whole equation which says. Okay. This is what KNN says. Now we'll have to capture a lot of things. You see, because I'm making assumptions. Now you can ask me questions, sir. How do you find the neighbors? Look, what do you call nearest? How do you measure the distance? That's the point, because I have to mathematically model everything. So this is a problem I model mathematically. So this should happen. So how to do this? So before that, I want to show you some failure cases where the KNN will fail. Failure cases. There are a lot of failure cases. I want to just show 2 or 3 maybe. So what is the first failure case? Let's suppose something is random. So there are these data points like this. If there is no pattern in the data, if it is total random, if it is totally random like this, and there is a Curie point like this, there somebody Curied it here. So there is no point in applying KNN, because you know KNN will give some answer, but it will be obviously rubbish. Why? Because these points are so random, there is no structure, there is no pattern in the data. Even if you see in the first, there was pattern. So there was some pattern. So it was logical to query a point and then see the neighbors. So if the distribution of points is totally random, so this is the failure case in KNN. Okay, because it will give some answer and we cannot trust the answer because we know that the whole distribution is random. There is no point. This is one failure case. And the other case can be if a point lies way longer. For example, if you have one cluster over here, and let's suppose you have one cluster over here. Let's suppose there was an outlier point somewhere over here. And if you ask KNN, K nearest neighbor algorithm, so what is the point, what is the cluster that it belongs to? It will probably say to this cluster, because these are the nearest neighbors to it. These are the 3 nearest neighbors. 1, 2, and 3 are the nearest neighbor. But it doesn't make sense to give it a cluster because it's way away from the cluster. Okay, so this can be thought as an outlier. So if there is an outlier, so it is like there it will make mistake probably. So because this outlier should not, even it should have better been sent. I don't know about this point because this is not closer to these points. But KNN, it will say like it belongs to the blue cluster. So there are other like problems with if you have unbalance and a lot of other things are there. But let's say like, there is these failure case or these limitations to the KNN. Now the question remains. Okay, now coming back to the KNN, what is the first step? The first step was to find k nearest neighbors. This was the first step. Find k nearest neighbors. Okay, then second thing was do majority vote. That's the second thing, because here you'll find k nearest and get their labels, get the labels, and out of these labels you'll do the majority vote. Now we have to define. I can ask you a question. How do I define a neighbor? Can anybody define a neighbor for me? How do I define the neighbor? So if I want to find my neighbor, so how to tell computers to find a neighbor?
Sir, distance, मतलब कि
Right.
closer the
Yes, yes, yes. Go on.
sir, closer the point is, so the nearest the neighbor is.
Right. We should measure the distance. Measure distance. And now the question is how to measure distance. That's the question. How to measure it? That's the question. How to measure distance now? That you have done. If you remember the first
Yes,
class of
sir.
algebra, that you have done.
Cartesian.
Yes, yes, yes,
Uh,
yes, yes. Now again, at least I have come across, I'll say, like 15 plus types of distances. Like in my career, in my studies, I have found like there are a lot of types of distance. How you can measure this distance? There are a lot of types of things that you can do. So I'll just introduce maybe a few of them and to give you a thing. So here I'm not teaching you KNN. That's not a point. My point is not to teach you KNN. KNN anybody can teach you. I'm teaching you how to think. I'm giving you a template how to think. When you are doing something, ask questions. The question here was the can I find the k nearest neighbors? Okay, how to define a neighbor? Neighbor means which is less distance. Okay, now the question is how to compute the distance. That's the difference. I don't want to give you the algorithm only. Okay, I'll give you the algorithm. This is how it is done. No, the whole process you should learn how to think. That is the whole point of education. The point of education should not to memorize. It should be to generalize. That is from this example. We should not try to memorize everything. We should try to generalize. So whenever you are reading something, do not focus on the only part that we are learning an algorithm. We are actually learning how to think. That's the whole point. So I gave you find k nearest neighbors. Then first I explained what k is. K is like the parameter that you can choose. Then we have a neighbor. Nearest neighbor is that the neighbor means basically which is near. Okay. What is the meaning of near? Near means distance is less. Now the question is how to measure the distance. That's the question. Okay. So there are a lot of types of distance. So now everything is a point. So everything in the data is a point living in some high dimensional space. Okay, if you have read about the algebra, then you know that if it is RD, then it belongs to a point RD, and we can find the distance between 2 points in RD. That's an easy case for us. So like let me again introduce those things like very quickly. So let's suppose we have only two dimension. Let's suppose. So we have a point over here. Let's suppose we have a point over here and we have a point over here. So x coordinate of this point is, let's say, x11, and let's suppose the other coordinate is, we'll call it x12. Okay, this is the first point, second feature. So here we have second point, first feature, and this is second point, second feature. Okay, now I want to find this distance d, the length of this. So how to find? If you want to find exactly what's the distance, we can use Pythagoras theorem. Really easy. Okay, so first we'll say d square is equal to, we'll say base, let's suppose this is base and this is, let's suppose, perpendicular. Base square plus perpendicular square. Why am I doing it? Again, I want you to derive all these things. When you are doing something, you should derive it. So what is base? So base starts here and ends here. So end minus start. So you will say x2 1 minus x11 whole square plus, what is perpendicular? It ends here, starts here. That's this x22 minus x12 whole square. This is d square. So distance d is equal x21 minus x11 whole square plus x22 minus x12 whole square under root. Under root means 1 by 2, raised to 1 by 2. This is called as Euclidean distance. Okay, what is this called? This is called as Euclidean distance, or this is called as L2 norm. You might have seen sometimes it is written like this: x2 second point minus first point 2. This is called as L2 norm, because norm is calculated for vector. So this basically is a vector over here. So this is a vector. This point over here, this line over here is a vector, and for vectors its norm is calculated. So what is this equal to? I can write it simply. I can write summation of, okay, so if it has, how many components it had here, it had a lot of components. Let's suppose two components it had. So I'll write x, the second point, first component, minus x, first component, first point, the same component, whole square. And what I'll do is I'll take the square root. Square root is 1 by 2. Is it clear? This is for, let's suppose I is
yes,
equal 1 to d. D means how some number of features it has. So this is one measure of distance. You can measure distance. If I give you now values for this x1, x2, this values for the corresponding coordinates, you'll easily measure distance. This is called as Euclidean distance. Okay. Then we have something called as Manhattan distance. My point is not to introduce distances again. My point is to tell you there are a lot of distances. So there are 15 plus. I can introduce how many? 3, 4, 5. So distance measure, first thing that we saw is Euclidean distance. Euclidean distance. Spelling can be here and there, and we don't care about spellings. We are from the era of keyboards where it autocorrects. So the second thing is Manhattan distance. So what is Manhattan distance? So you saw this, the same picture we had over here. So Manhattan distance now says do not use this Pythagoras theorem, directly add this and this. Add directly, like directly add these things together, and then you will get this. So what I'm saying is it says directly add distance is equal base plus perpendicular. Okay, and the absolute value of these, basically the absolute value for base, absolute value for perpendicular. So what is the meaning of that? So how to compute base? The base was x second point 1 minus x first points first coordinate, and then take the absolute value of this plus second point second coordinate minus second first point second coordinate absolute value. Okay, and then no norm is being taken, no square root, nothing. Okay, so this can be written as like this: summation of x 2i minus x 1i, x I1, maybe 1i is also x 1, and then you have to put a mod over this. Okay, then this is written like this: x2 minus x1, this is called as L1 norm. This is again a distance. Why is it called Manhattan distance? I found a guy giving an explanation of this. So he said if you go to Manhattan, so their cities are planned. So they are in blocks. So this is called as first block, second block, third, fourth, fifth blocks like this. So if you have to reach from this house to this house, so you have to follow this like this, because this is how roads are made. They are basically made in a matrix formation. So that's the reason you have to follow this, and then this, then this, and then this. That is why it's called Manhattan. So Manhattan is a, I think, a town, so where the whole city was planned like this, and they are separated in blocks. Okay, this is called as L1 norm. Then we have something called as, which is usually used, which we call as LP norm. It's called as Minkowski distance. Minkowski distance. Okay, so what is Minkowski distance? You again take, but you take the pth norm. So what you will do is you will raise it to power to the p, and then instead of square root you will take 1 by p. So it is x2i, let's suppose first component of the first component of the second data point, minus x1 1, and then you will raise it to the power of 1 by p. Now you will p it, like you will rather than squaring, you will put the raised power p, then plus you will say x second, then second component minus x first second component raised power p, and keep on going, and then you will raise it to the power of 1 by p. If I need to write it, I'll write it summation of how so many features, 1 to d features are there, x2i minus x1i, this is the ith component of second, ith component of first, and then take it to the pth power, then whole of this raised to power 1 by p. This is called as LP norm. Okay, so it is written like this: x2 minus x1 of p. This is the value. Okay, so what is it called? It's called as Minkowski distance. There are other distances as well. For example, it depends on the vectors. I know a distance called as Hamming distance. Hamming distance. I'll maybe tell you applications of this also. So what Hamming distance is used. So let's suppose you have the binary vectors. You have binary vectors. Let's suppose we have data points x1 and data point x2. So this is like 1 0 1 0 0 1, something like this. Then you have some other point 1 0 1 0 0 0 1 0 1 0, something like this. So what you do is you see how many times that is. So Hamming distance, Hamming distance of x1 comma x2 is, so number of places they have opposite values. So what's the meaning of that? Here you will see 0 plus 0 because it's same, plus 0 So where is it? So it is disagreeing here. So here the distance is 1. So we say that Hamming distance is 1 because only at single, if you call it bits, so only at one of these bits they are disagreeing a value. So rest is whole of the rest is same. So we'll say that Hamming distance of x1 x2 is equal to 1 because they just disagree at one single point, one single feature. So all the features are same. So why is it required sometimes? Sometimes if you know about gene sequencing. So how many of you are biology majors? Have you read biology at any point of time after your 10th?
Yes, sir.
So I myself belong to that. So there is something called as gene sequencing. I think the guy's name was Alec Jeffrey, if I'm correct. So what did he do? So we have 4 base pairs in our DNA. If I'm correct, maybe I can be wrong, but there are only 4 base pairs: adenine, cytosine, guanine, and thymine.
Government time, yes, sir.
So these are the 4 base pairs by the help of which our whole DNA is made, and they have a whole sequence. So it can be like adenine, adenine, cytosine, guanine, thymine, thymine, adenine, something like this. Okay. So let's suppose this is one DNA sequence of one person. Then DNA sequence of second person will be like this: adenine, adenine, cytosine, guanine, guanine, adenine, adenine, guanine, something like this. So then you will see how these base pairs match, these pairs match, and here it is justified to find Hamming distance of DNA 1 and Hamming distance of DNA 2. Okay. So here you can see that here they disagree. Okay, and wherever they disagree, here they disagree. So here the Hamming distance is 2. That's why you might have seen DNA of, let's suppose I'm oversimplifying it, but it's okay. You get the point. So DNA of these monkeys, or let's suppose, is 99% similar to DNA of humans. That's why they actually compare these gene sequences. And how to do that? By using the Hamming distances. Is the concept distance clear?
Yes, sir.
Okay.
Yes.
Yeah, we'll maybe close the session over here, and then we'll take on the distance. So we have clear with the distance. We have to compute the distance, and then let me again talk about the majority vote a bit, and then we can close this because I need to introduce the similarity scores and stuff like that. I'll introduce that in the next class. It'll again takes a bit of time. So last thing for the day is what is the meaning of majority vote? So what's the meaning of majority vote? There is an algorithm of majority vote. Okay. So if you have an array, so even if the people among you who are solving DSA, so they'll have seen this this majority vote problem. So now the problem changed in the algorithmic problem. Okay, now you'll have to find the ways. So majority vote means, let's suppose you have uh, 10 elements now because you have 10 neighbors, let's suppose. So among the neighbors there are two types of classes. It can be either one class, zero class. So it will be like this: 1, 0, 1. So how many are these? 3, 9. So one more is there, 0. So majority element now means that that element should exist greater than n by 2 times. Okay, so if here, so it should be at least 6 times. Okay, 6, 7, 8, and 9. So whichever element is greater than n by 2 times, that we call as a majority element. So here 1, 2, 3, 4, 5. Let's say we have 11 elements now because it was a tie. That's 1. So here 1 is a majority element. Why? Because 1 is present 6 times. So now the first thing was we had a problem. We solved the distance problem. Let's suppose we got it solved. We did mathematics, and now we are also having the labels of these things. Now you have to solve this problem. Now it became an algorithmic problem. Okay, now you have to find an algorithm again to uh, see how to do this majority vote. How to find this? How will you do it? Like let me get you ideas from you. So how do you think you will get it? So you have to find an element which is in the majority. So how much time will it take?
So, sir, we can sort this and then,
Sorting will take analog and time.
yes, sir. Sir, we can use heap also.
Still,
Map.
sorting will take analog and time, no matter what you do. How to do it? Like it's a really easy problem, and even you will have to see if it is really a majority element. And sometimes it cannot be only 2 elements. So I said in 2 elements n by 2 times. It should be present n by 2 times. So sometimes what you have to do, you may have 3 classes, 1, 2, and 3 classes, and you will have to see which is present greater than n by 3 times. The element which is present most of the times, basically n by 3 times. You'll have to find the algorithm for that. I don't want to give you the algorithm. अपने घोड़े को दौड़ाओ and then see where you will reach, and you will have to get in order. I think it's n by 2 is possible. I don't exactly know, but I think n by 2 is possible. No, n by 2 is not possible probably, because you have order n is possible. Yes, order n algorithm is possible. I am getting an algorithm in head that's order n. So that will just take one iteration to do all of this. Okay, and find the majority element. And there is a beautiful problem of majority element. So there will be, for example, 10 elements, and you will have to see which element is present greater than or equal to n by 2 times. So this is actual majority element, but here we don't want to find that n by 2. So we want to find based on the number of classes. So which are element exists greater number from others, that is the majority element. So you saw the problem again, going back to the thinking process. So we first had intuition in the head. We had that, okay, so even you told me this k-nearest neighbor algorithm, so there was nothing new. Every Tom, Dick and Harry would have easily guessed it. Would have said, okay, if you give me, I think birds of the same feather flock together. So this is that. But now I have to mathematically model it. First I measured, okay, I need to say, set the k nearest neighbors, and now I need to define the neighbors. I said that neighbor is a guy who is at the very less distance. Now I need to capture how to measure distance. Or I came up with different measuring tools of the distance. I said there is something called Euclidean distance, there is something Manhattan distance, there is Minkowski's distance, there is this Hamming distance, and there are a lot more distances. If you search about these distances, and you will find a lot of tools to capture distances. And in the next session, maybe I'll also introduce something called as cosine distance, cosine similarity, and things like that, because that's important. And after finding the distance, now you are able to see what neighbors are. Now you are done with the finding neighbors. Now for the neighbors, you'll have to find the labels. That's easy. You'll just pick up the neighbor and see its label. Now you'll have to do the majority vote. From the algorithm, now from this mathematical modeling, you came to the algorithmic thinking now. Now you have to come up with an algorithm which will find this majority vote really fast. Okay, and from this you'll have to again, and you see how you broke down the whole problem. Again, last point I'll say is, my job here is not to give you algorithms. These algorithms are there written in books. A lot of books are written there are a lot of blogs, and maybe some other people are teaching better than me these algorithms. But one thing I can do better than other people is to teach you how to think. If there's an algorithm, you should be able to dissect it like this. So I don't want to read the algorithm. That's not my job, because
So we can also
anybody
use
can
count
memorize,
here.
huh?
We can also use count here.
Count on this, huh? Yeah, that is order. But I'm saying majority is actually this. So if you have, let's suppose, 100 types of elements, and you want to see which of the element exists n by 2 times, you'll have to keep 100 counts then. You
Yes, sir.
find like there you'll find 100 counts, and then again see, go iterate over those counts. The worst case, again you will have to iterate it at least 2-3 times. You will have to see that.
Yes, sir.
And it's a famous problem. You can just go on lead code and find majority vote algorithm. No,
Thank you,
you
sir.
are actually interrupting me. I was telling you something new. I was telling you my job here is not to memorize your algorithms. My job here is not to teach you an algorithm because you can find anywhere. My job here is to teach you how to think. Okay, I'll stop recording here. If you have any questions, I'll take those.